In this video, you will learn about integration testing, its importance, example, different ways and techniques to perform integration testing. So let's start. First, we have what is integration testing. Integration testing is the type of functional testing. This is the second level of software testing and comes right after unit testing. Means after unit testing, we perform integration testing. In unit testing, individual units are tested. Now, the next step is to combine those individual units and test as a group, and to verify that multiple units are working fine together or not. These test how well different software components work with each other. The purpose of integration testing is to expose the defects appear while integrating different modules or units. Unit testing is performed by developers, while integration testing is performed by QA engineers or testers. Unit testing is performed in development lifecycle. On the other hand, integration testing is performed in software testing lifecycle phase. For example, in unit testing, module 1 is developed and tested by developer A. Similarly, module 2 is developed and tested by another developer B. So after unit testing, those two modules are integrated and testing of that combination of module 1 and 2 is done by QA engineers. Next, we have importance of integration testing. When we develop any project, the project is not developed by a single developer. There is a team of multiple members who work on that project parallelly on the modules assigned to them. So they work on the assigned module and test it completely and resolve all bugs in that particular module. But at the end, the complete project need to be delivered to the client, right? So in that case, we need to combine those individual modules developed by different developers and test the integration of those modules. But there is a point that all modules are already tested individually, then why do we need integration testing? The answer is that although during unit testing, each module is tested individually and bugs are resolved, but defects still exist due to various reasons. Each unit is developed by a different developer and their level of understanding and way of coding may differ from other programmers. Even when code of multiple developers is pushed in single branch, the integration testing becomes necessary to verify that those modules are working properly in Unity. The goal of integration testing is to check how system will perform when combining different modules of multiple developers, and those modules are developed as per the requirements document provided by client. Another issues could be at the time of development, there are chances of change in requirement by clients, and those changes may not be tested properly while unit testing. It may also happen that some defects might be skipped by developers. There are softwares in market which may interact with third-party tools for the services. This interaction is also covered during integration testing. Performing this testing will also help you to check the structural changes when a user moves from one module to the next module. You can reduce the overall number of bugs and increase performance by fixing issues in the integrated modules. Next, we have example of integration testing. Here is one example where different modules are interacting with each other. First test case is to verify the interaction between login and inbox modules. Enter username and password on login page and click submit button. If the username and password are correct, user should be navigated to inbox page and all the emails should be displayed on inbox. The second test case is to test interaction between inbox and delete email modules. On the inbox page, select any email and click delete button. The email should be deleted and disappeared from the inbox and should be displayed in the trash box page. So this is the basic example of integration testing. Next, we have techniques to perform integration testing. There are mainly two techniques. First is Big Bang technique. This technique is used when you want to start performing integration testing once all the modules are ready from all developers. Means the development of all modules is done, then the integration testing is started. The testing will not be started until all the modules are ready. This approach is normally used for small projects. This approach is not suitable for large projects because all modules are tested at once. The risk will be more increased, and to fix the bugs, the time, effort, and cost will also be increased. So we have another technique which is majorly used for large projects to perform integration testing, which is called as incremental testing. As the name describes, the modules are integrated in an incremental way, means initially integrate two modules and test them completely. After that, combine third module with those modules and test them. Similarly, add next modules and so on. The process continues until all modules are integrated and fully tested. To perform integration testing in incremental way, we have three approaches. First is top-down approach. So based on the control flow architecture diagram of project, the testing starts from top level. Means the top level modules will be tested first, and after that, bottom level modules will be tested. Then integrate both top level and bottom level modules to check whether the complete system is working fine after integration. In this approach, for example, top level modules are already ready, but few developers are still working on bottom level modules. So we will not wait for them to complete their modules. We will start integration testing for top level modules and use stubs in place of modules which are not ready for testing. So a stub is a small piece of code which is used in the place of a particular module for testing purpose if that module is not yet ready. The stub returns the same output as that of the actual module. We use stub when we don't want to put the complete testing on hold if few modules are not ready. So this is top-down approach. Next, we have bottom-up approach. In bottom-up integration testing, the lower level modules are tested first. Then these modules are further integrated to upper level modules and test them. This process continues until all modules are not integrated and tested up to top level. In this testing, integrate or join modules by moving upward from bottom to top as per the project architecture. As we use stubs for temporary purpose in top-down approach, in similar way, we use drivers in bottom-up approach and use drivers in place of those modules which are not ready for testing and returns the same output as the actual module. Last, we have sandwich approach, which is a combination of both top-down and bottom-up. It uses the benefits of both top-down and bottom-up approaches. It uses both stubs and drivers. In this approach, test top-level modules with stubs first and bottom-level modules using drivers. Then combine all those modules and test them as a final layer. Sandwich testing is used in very large projects. It allows parallel testing, but this approach is not suitable for the projects which have a lot of interdependency between different modules. Thank you so much. Let me know in comment section whether this video is beneficial for you or not. And also let me know if you want next videos on which topics. So don't forget to like, subscribe, and share the channel Automation Exercise.